Okay, this is the P3 paper from January 2023. It's question number 8, and this is integration, and in particular, integration using trig identities. Let's have a look at the question. So we can see it says the integral of 2 cos x minus sine x all squared. So let's write it out. Integral of 2 cos x minus sine x all squared dx. So first thing to do is to just multiply that out. So the integral of, I'm not going to take any time over this, but if you want to break up into 2 brackets and multiply 2 brackets together, you can do that. We're going to get 4 cos squared x. We're going to get minus 4 cos x sine x. And we're going to get plus sine squared x dx. So hopefully at this stage then you've practiced all your different integration techniques. I don't like cos squared or sine squared. What I'm actually going to do is change the cos squared to 1 minus sine squared, get everything in terms of sine squareds there. And once I've got those, I'll see if I can do anything with the sine squared. And the 4 cos x sine x, really, really important you know your trig identities really well. If you know that sine 2x is 2 sine x cos x, then it's not a difficult step to see that 2 sine 2x is going to be 4 sine x cos x there. So I'm getting rid of this middle part. The cos squareds and the sine squareds, we'll do something about those in a second. So trying to do this all at the same time is the integral of 4. Let's change the cos squared to 1 minus sine squared. Let's change that minus 4 cos 2x, cos x sine x into minus 2 sine 2x. Let's leave the sine squared alone, and then we'll combine all the sine squareds together in a minute. So I'm going to have the integral of 4. It's minus 4 sine squared plus that sine squared, so that's going to be minus 3 sine squared, and then it's minus my sine 2x here. And then the sine squared, what I need to do, again, using a trig identity, so what we should know is cos 2x in its various different forms. It's cos squared minus sine squared. It's 1 minus 2 sine squared, and it's 2 cos squared minus 1. I'm going to be using the 1 minus 2 sine squared to now rearrange this. I'm not taking any time over this. You're going to have to do that yourselves, or actually, you know, some of my students, my really, really good students, they've actually learned this half 1 minus cos 2x. Because they're aware of the fact that they do need to be able to integrate sine squared or cos squared, and so they've learned what they are in terms of double angles there. But so then that means that I've got the integral of 4 minus 3 sine squared. So 3 sine squared is 3 lots of a half 1 minus cos 2x, and then minus my sine 2x. Let's put the dx in there. Let's put the dx. And tidy up the handwriting of that. And now, only now, I'm at the stage where I can actually integrate this. What you could do if you wanted to was to tidy up what 4 take away 3 over 2 lots of 1 is as well. So we may as well do that before we integrate as well, sorry. So we've got 4 take away 1.5 gives me 2.5, 5 over 2. The minus and the minus there is going to make that plus 3 over 2 cos 2x, and then still the minus sine 2x dx. And so now, actually, finally, I'm at the stage where I can integrate these. Integrating 5 over 2 is just 5x over 2, and then the integral of double angle, I'm not going to spend any time over that either when we're actually looking at it. The integral of cos 2x, I guess just really quickly, I would guess that my integral is sine 2x. When you differentiate sine 2x, you get 2 cos 2x. So the integral of cos 2x would be a half that. But as I say, really at this stage, you shouldn't be needing to do that. You should be able to do these straight off the bat. So the differential of that is going to be a half of 3 over 2. So that's 3 over 4 sine 2x. And then the same, integrating sine 2x is going to be cos 2. Was that 2 sine 2x? Where have I missed something off? Yes, sorry. Apologies here. goodness sake, but at least I've spotted it, that all the way through. Then apologies, I'm not going to go back and do it again. That's 2 there, which is 2 there, which is 2 there. So when we integrate 2 sine 2x, yeah, we're going to get plus cos 2x there. The integral of minus sine is cos, plus my constant there, and then that's it all worked out. I know I went quite quickly through the integral of sine 2x and cos 2x, because at this stage I would expect you to be able to do those two bits relatively straightforward. If not, you need to go back to your bookwork and practice a little bit more. But apart from that, yeah, taking the trig, using the identities as necessary to be able to change it to something that we can integrate is a key skill. Hopefully that all makes sense.